Hello, everyone. I hope you're doing well these days. Today's topic we will talk about USD and Solaris and how can we caching stuff to make um, various simulation for production like flip fluids and rigid body simulations with structuring and pyro simulation. We are not, we are well not talk about the beauty and physicality of things, but we are talking about the setup, the technique. How can we make things working correctly and successfully? So our video is split into in two chapters. First of things, I will talk about the theory, and the other part we will talk about the simulation itself and caching. Okay. Let's take a look about the normal environment in production. So we might receive a scene like this one. We are in the FX department. Before us, they're modeling and texturing and lighting and layout. Not lighting. I think lighting after FX. So modeling, texturing, layout, FX, lighting, so render. So we are receiving a scene like this. So the art director came with a brief. So he needs this jar to fall down and fracture and start falling from it some oil and make it fire from this oil to this um, thing. I'm not sure. Let me check its name. Bloom, I think. Yes, broom. Broom. Okay. So here is the normal workflow. We won't override this thing, the overlay. We need to overlay transformation and make things happen to it. So finally, we can generate a file, a USD file like this one, and append it to the whatever it come. Okay, so we sublayering it. So here is our task. Okay, so this is the final goal of our workshop. Fine. So let's talk about the idea we need to discuss about. Okay, so as a normal task of FX, we can make a VLAN simulation like this, pretty standard stuff. But the thing we can do with that, at some point we can cache our work to continue working on this cache or for exporting it for other departments. Okay, so we cached it once. Okay, so what if I need to export this cache to another department so they can light it? Okay, so I export it as bgeo, then I need to export it as USD file. How can I export it? I need to import this null here. I copy it, paste it, and configure some data here and make it on disk like this. And I can send him this file. Okay, so what happens now that I have cached it twice on disk? Let us check. So here is the bgeo. Okay, here is the geo about 12 megs, and here is the USD file, almost same size, but USD more compressed. Okay, so we are almost duplicating the data on disk. We can consider this for flip or something huge. We need to make it twice, but that's not efficient for my site, for my taste. Okay, so this is the normal workflow, the standard workflow. So I came up with a new idea that why we can't replace bgeo with usdc, as we saw that usdc is more light and more, it will be more for future usage. It can usdc or usd format can widely distribute in the future because the rapid growth for the USD techniques or workflow. So why we can't replace the bgeo extension with USD extension, and at the same time this USDC can be working in same file of Houdini normally like bgeo. Okay. Okay, so it's a normal thing that I need to make USD export here. Okay, this thing and USD import again. So this like file cache, normal file cache. Here we are writing this and reading it back. Okay, without with different extension, but here will appear some issues. We will discuss it. Okay, so here we can specify a folder like this folder, for example. Here usd cr dot usd. Okay, so let's assume that we are need to bake this as USD and reading it back for SOPs and continue working like bgeo. Okay, so I can read it back here. So let's make it frame range and save it again and reading it back. So I have now one backed USD C here, but I need to unpack it to polygons. Okay, so here is the problem comes out. If I compare the attributes and groups for this this kind of workflow and compare it with bgeo, we will see difference in attributes. So I was have 31 point attributes, now became 32 point attributes. That's not the problem for myself. Okay, I got here a problem in the detail attribute and primitive attribute. I was have just one primitive attribute. They became 9 primitive attributes, and the same thing for detail attributes. So yes, it's a problem for me. Why my groups are messed up? Okay, let's talk about another example, and I will show you the correct way or the new way I came up with. Okay, so here it is another example. Okay, some particles. Okay, I can cache it and read it back. So here is reading back, and let's compare the attributes with original bgeo for example. So here is the problem. I was have point group. I don't have it anymore in USD in this technique. Okay, let's talk about volumes. Okay, let's talk about volumes. So let's cache about 20 frames, 25 frames. any volume we can talk about and see the results. So I got this thing here, and when I read it back, okay, it become like this. It's totally different. First of things, we have underscores instead of dots, like here, val.x. Here we have val underscore x. Difference. We, like here, got tons of attributes being converted from details to primitives. Let's check here. So we have all of these for visualization, and some of them came from DOPS. It was on detail attribute, they become on primitive attributes. And unfortunately, I don't know where come from, where which one of these attributes were details or primitive. They are mixed up together. So that's a problem for my taste. So here is the solution to USD Cache. Okay, this tool doing same thing like exporting USD and importing USD with preserving the attribute correctly. Let's check first the VLAN solver and compare it with file cache. Okay, let's save it to disk. When it's saved, it's getting this badge here, so it's telling me that file exists on disk. Let's compare the attributes now, and let's compare the bgeo attributes and usdc cache attributes. Here file cache bgeo, and here usd cache. We got about same attributes on point and same attributes on USD Cache. Almost same primitive attributes. We got new attributes from USD, unpacking, name and path, and we got same point attribute, primitive attribute. We got same detail attributes. So that pretty useful for me. I can now delete this file cache and wire it up here, or I can use this file cache, new file cache I created for another simulations. So let's say if this torus falling on ground, but not falling ground, falling in tank of water, so this file cache I will need for another simulation, they will interact together. Okay, so for this stage is working fine for me. Another useful or handy tip that we are now, let's make it unique name, Willem sim, okay, and cache it again as I'm reading from $OS. I can for now make this here, copy this file and get back to LOPS. And for this time, I don't need to configure a new layer on this. Already it configured out. Okay, so all I need that reference or loading reference this file on disk here like this, and yes, here, and make it default, and just save this as one frame, current frame. We don't need to flatten anything, and we can type USDA as final thing here, and we can read it back. So yeah, we don't need to configure or recache the simulation. That's it, the idea. That's it. saving out the space on disk and optimizing things out. Okay, let's try this method with other um, types of geometry, like volume, for example. Okay, USD cache here. I can wire it here and make Biro solver out of it like this. Okay, and we can save it now as 25 frames and save to disk. Now I got volumes like this, and when I read the cache again, it's still same. It's still I preserving each attribute on geometry like the original one. Okay, so here is my detail attributes. Let's make the bgeo here. I got same detail attributes, I got same primitive attributes, I get same names. Here is I have val.x, same, it keeps the same name. So this my method, this original one, and we can check this one here. So this is a standard one. So attributes is different, names attribute different, detail attributes and primitive attributes are mixed up, and this is my way. Okay, cool. So same thing works well with separate points or unconnected points like this. We can check it together, and here I can save it like this and save it to disk. Here I can read it back and check for the attributes and the groups, and this is the original one. So here I'm getting also same attributes as the original. I get same group, I get here same group. The default standard one, I didn't get point groups. I'm not sure this happens why. I think Solaris is still working in progress. But for this time, I need to make a workaround. Okay, so let's move to the part 2 to make other effects and caching it without needing for bgeo. Okay. Okay, so I can bring assets like this. As I said, you can download this asset from this link. It's free and anyone can use it. So you can follow up with me. So let's start working on fracturing this jar and make it fall to this direction. Okay. First of all, I need to select this from scene graph here. So I can select this reference 7 and go to SOPs and create geo and sub lob import to get this geometry from SOPs and from LOPs. And here is the stage, this import. I can specify this reference. So I got this button. By default, it came in with static animated sequence. So each frame it will be calculating. So it might be calculating the fracturing and other stuff. So it's possible, but it's preferable way to make it static. Okay, so I need Here is I have back USD. I need to unpack it to be geometry, normal geometry to start fracturing. Unpack it, USD, unpack to polygons, and get it like this. Okay. Okay. So first step, it's very crucial for bullet solver to work with the name attributes. So let's check the name attribute we got unique names, but I want to preserve the path attribute. So I will convert this name attribute, I will delete it and use the path attribute as unique names. So when I return this geometry for loops, I can get the same path for each mesh. Okay, so I will rename attribute rename this to the name. The path will become name. It will complain because the name already exists, so I will override even if it exists. So this will be my name. Why I made this? Because I need to make this mesh here. If you remember, the scene graph was like this and holds some meshes inside of it, cord and handle. These are meshes. I will treat these meshes like parent for childs of fractures. So the fractures will be childs of this parent for this mesh. So this mesh will be X form. Okay, like container for some pieces. So let's split this part firstly and to start fracturing it. So I can select here by name and select this one. Okay, scatter like 3 points and make Voronoi fracture and fracture it just like this. Here, the very important step that we need to preserve our names. We need to add to it or append to it. So here I need to append to it. What thing I will append to it? Each piece I just created. So this piece 1, this piece 2, this piece 3, whatever, I need to append it to my current mesh. Here I just have appended it, but I need to make a parent and a child. To make it happen, I need to separate the old path with the new path, and here we can type jar piece just like this, whatever, but something this can make it describable. So we have some pieces for jars like this 0, 1, 2. So we have in total 3 pieces, and here is the parent and here is the child. Okay, so I can merge it back with the org here. So we are ready to make a simulation, but I need to bring some of colliders like this table, this elements here, and maybe this one and this one. That jar may collide with them. Control C, or here copy path, and here we can duplicate this here and get these primitives. So we have now some primitives. We can treat them as collider. Okay, so for reference, I can make this for collider call, and this will be input. Let's make it another time. Okay, let's remove the visualizer and start making some RBD things. So here I can make RBD configure, to make these Olympic not bagged fragments for bullet solver to work with. And here is the collider. I can get it here and make convex decomposition for these pieces. Okay, so these fates will work fine with the bullet solver, and yes, RBD bullet solver. For sure, I will need some constraint network here, so I can wire this here and make constraint network from rule. So I can generate some of constraints here. Okay, and I can give these constraints some constraint properties like glue and tiny strength. I need this jar to be broken pretty quickly. And let's check the collision and the simulation. For now, it's falling in this way. So here I can give it some initial velocity via v. So not in z. Okay, something like this. Let's make some ground here. Yes, ground plane. So yeah, let's make our duration 100 frames. There's something like this, but it's keeping rolling because the collision shapes. So I need to lower this padding quite few. Yes, more stable and pretty good. Okay, so at this stage we need to cache our simulation. So to cache it with newer technique instead of bgeo, I can make use of USD Cache here, and let's say this USD or X for BTS. Okay, save to disk, and let's transform. Yes, we have some transformation points, and let's transform pieces to this bagged fragments here. Okay, it's not working because missing of names. Here I just override the name which it was here. So I was got these names and now become to these names. I need to convert or rename again the path, this path to become names, but on points. Path to be name. Yes, it's working pretty well. So we are matching names. Okay, I need to return this mesh back to stage. Okay, so I can make here a null and type to not like this. I can make use the hash again. So this layer will store our fracture geometry and transformation data we created. Okay, let's say RBD layer. Okay, and we need to configure the primitives before we transfer this or reference this to stage. First of all, we need to I don't I need to make it in a stage firstly and make it using USD cache to demonstrate some information here. So first here to LOPs, and I can copy this node to stage here, sub import here. So I'm bringing some geometry from SOPs, but it's not working, and it's like normal messed up. What if I render this geometry? I see that collision, this geometry treated as subdivision geometry. Okay, but I don't need to make this like this way. So I need to remove the attribute which controlling the effect. If I checked here, the detail attribute, I got OSD scheme Catmull Clark attribute. So this attribute, if I transfer this attribute to stage, it will make geometry should be subdivided in render time. So I need to remove it. Here, and I can remove it like this. Okay, if I go back, yes, our mesh is clean now. Okay, our problem got fixed, but we still have some other problems. What is the other problems we have? Here we can see our container, as we told that we have a container and inside of it some pieces, or we have now parent and some child. So this is parent, these are childs or pieces. So we see duplicates of these, and we see prototypes. So when I bringing it by default, the primitive definition makes the backed primitive as instances. So I have put type and blue primitives. So it means that instanceable geometry or primitive. Okay. So here I can make it X form, so it not become instanceable, but we have duplicates. Why these duplicates happens? Because we bringing the path attribute and the name attribute. So let's check the scene graph, the network we have. So here I have name attribute, that's correct, and here yes, our names is messed up. Okay, so first of all, I need to attribute rename and convert the name to be path. Okay, the name here, name will be path attribute. Okay, so we got names, but still the problem persists. Okay, So I would have here names, and now I got path. So I just need one of them so I can get the path only. So here the problem fixed. Okay. So I got 3 pieces for this parent. If I, yes, here it's working. So transformation matrix, get back. Okay. If I check any meshes from these meshes here, I see a lot of green attributes. That meaning that these attributes are time sampled. That means that every frame I have in my sequence, I will write this var. So it will be redundant. I don't have any deformation in points, or I have any animated normals. So I need to hold these attributes and write it once. Here is the handy parameter. I have the default value. So I will tell it to be everything is default besides the velocity and the transformation matrix. Transform here. Okay, what is the transform attribute I'm holding? This one. This X form called transform here. So this I need to be animated, and the velocity I need to be animated also for mantra or karma, sorry, to make motion blue correctly. Okay. First of things, I need to check that the backed primitive here got an intrinsic attribute. The back default transform here, it got same data. So 0.937. This primitive I'm holding up. So here the transformation and in a stage, and here is this same transformation in SOPs. So this number will match this number. Fine. So this attribute should be animated before calling this geometry at stage. Okay. I think we are done for this time, and we're ready to go. What if I sublayer this new SOP import to original layer here and here? Okay, the drawer firstly got the right materials, and it's getting the animation, but I see it's doubling the transformation. Because this happened, why this happened? First of all, this reference, this parent of my parent got transformation matrix here. When I bring this geometry to SOPs, it baked this transformation matrix into the point I have. Okay, so when I return this baked out transformation back to to LOPs, it doubled its transformation. So here I got transformation from TOPS, and here got transformation originally from LOPs. So I need to zero out this transformation before I getting back to LOPs, sorry. By what I mean by zeroing out this value, by make this transform matrix to be identity matrix. So when I multiply this identity matrix with original matrix, like I'm multiplying a number by 1, so it's identity matrix. We will not affect or make it double transformation like this. So how can we make this happen? Here I was have USD X form matrix. It's very handy. It told me that geometry were in the rest position at 0, 0, and it got transformed to this position. Okay, let me check. Here I need to make an input or null. Here I'll call it input, and let's call it here. So I need to copy this transformation matrix back to our simulation. So how can I copy it? By attribute copy, and wire this here and type this here, USDX form. So now my geometry got USDX form. I can simply transform this geometry by this attribute by attribute transform my attribute, transform by attribute, and let's choose the USDX form instead and inverted, and let's check the output. Now the jar become into the 0, 0. Okay, so this now the identity matrix. When I call it back to Solaris, it will multiply the identity matrix of these matches with the parent, so it will be same. Let's pretend that we are multiplying number with 1, so it will be same. I hope this sound be not very complicated, but please rewind the video, you will get it pretty soon. Okay. Okay, good. So we successfully overwrite this jar with new SOP import. But look how very lag. We scrubbing with 4 frames, 4 frames per second. Very laggy for very small effect, because this layer should be configured. So I don't want to be configured here at LOPs. I need to configure it at TOPS, because the configuration at top will affecting the other simulations I will make. Okay, so let's configure it here and sublayer this file to NOPS instead of sub import. Right? Let's make it again. We don't need any instances. We need only just path, and here I need everything to be static, and I can choose velocity and transform to be static, to be animated or time sampled. Okay, and just hit save to disk. Let's call this from here. Okay, so sublayer. Here I found that I copy reference from my my USD cache. Okay, now I can just replace with it here. I think it's working, but viewport lagging. Okay, let's check. Yes, I think I missed the path attribute. Yes, I need to bring grabbing it from here. Okay. Let's pretend that in scenario that we are need to make newer version, so simply I can choose another version, increasing the current version, and save to disk again, and here in stage it's getting version 2. Now I think we are good to go. So look the scrubbing here with about 40 to 30 frames. So it's pretty fast operation. Okay, let's go through other um, simulations. But I will copy the template file to make time shorter. Okay. Okay. Let's back to SOPs and I will paste the flip simulation and the pyro simulation template. So I get this input. Okay, adjust it a little to get these shapes, peak it a little bit, and scatter a lot of points inside of it to treat these points for flip simulation. Okay. Okay, so here thing we need to know that let's make sure that I'm grabbing this here. Okay, so I'm getting the file cache I made and I get the input that originally came from stage. Okay, so I'm bringing the cache I made. Okay, unpack the cache I made here and make reversing the transformation I made. So I don't want this geometry to be in 0, 0 at the origin space, but I need to return it back to original state with USD X4 attributor matrix without inverting the matrix. Okay, so I'm multiplying the original matrix with the identity matrix to move it above the table. If I check the table, so this is original state. It was at origin and it become above the table. Okay, make it static and make some collider for flip. Pretty standard technique. I'm not creating something different, getting some viscosity, lower the particle separation for getting better resolution, and that's it. I don't creating something fancy here. I just increasing substeps and turn off preceding and make the viscosity here, lower the padding of simulation here, bringing the flip simulation and compress it, okay, and cache it with USD cache. So let's check this cache. Okay, the mode here is different from other or the standard mode. I need to stitch each frame and write each frame of the simulation and stitch it back to one file. Okay, so when I double check in the folder in the disk, I can check here each frame got be its own USDC file. Cool. And I got one stitched file that can when I at frame 1 I can read frame 1 of USDC. When I frame 2 I can read this USDC. Frame 3 I can read this USDC and going on. Okay, so this is stitched method. So when I can choose stitched, I can choose stitched with huge amount of data. So if it one frame, one file, the file will be like about 100 giga, for example. But when I choose the stitching and each frame will be small tiny bit and one file will reference all these tiny bits to one file. Cool. Okay. making a mesh here. So let's choose a frame. Here I got quite few particles and make mesh from these particles, but standard mesh. And again, I need to copy the USDX form from original state to the current simulation. So it's not happening at this place. I need to make it at origin. So I copy transferring the USDX form and transforming it back to 0 using invertation, the invert, and delete all attributes and keep b scale and velocity only. And here is the flip mesh cache. Cool. Here is the result, and it's pretty good, pretty neat. All attributes are nice and pretty fine. All I need that to sublayer this layer with the current one I have in stage. So I click here and back to stage. Here is the flip mesh, append it. That's it. I can check. Here is the flip simulation and the RBD. But I see that my RBD here, it's a newer one from the one I made. So let's copy the simulation. So here is the simulation, the old simulation points, the old cache, and we can remove it. And sorry, not removing it, but here paste the old cache and recache this again. We can make it version 3 or override version 2, it's fine. We went back to Solaris. Okay, I see that not working also because I think named attribute messed up. So let's get this, Control C, and here let's copy the path on disk and paste it here. Okay. So this is the original simulation I made, and when I see here at stage, yes, pretty good, matching and working nicely. Okay. So what is the other step? Making some fire when the liquid touches the blue. Okay. Okay. So here I'm getting the flip mesh, I'm getting the transformation matrix, I'm getting the collider, the broom, and transferring the flip mesh from the rest position or identity matrix to its original matrix or its place. Make attribute, transferring this attribute here so I can get burn attribute transferred to this mesh here. Yes, so I can trigger some fire from this red area by scattering some points, make volume, and here is a biosimulation, not very complicated one. So I'm not make anything different, some basic stuff. And for the solver or the pyro itself, I'm inverting or multiplying the current position with the original matrix to make it in 0, 0, the identity matrix. So here is the result. Here is the result. It's happening in 0, 0. This is the correct transform. I just file in SOPs back in LOPs, sorry, here with the sublayer. I'm getting the pyrosim here and just displaying it here. Yes, it's working pretty nicely. Yes. Okay, but if I fire up Karma, it will be not rendering right because of I need to assign shader for the fire. Okay, let's check. And here is smoke tinted with black. So that means it needs a shader. So I can create a material builder, yes, material library, and make here karma preview, pyro preview, xview preview here, and assign this pyro material to my volume. I found here my volume as one important note I didn't mention, that I need to specify the path or the current location to be my primitive will live in. So I'm getting the reference 7 and the handle the jar and write or append to this location my current volume or my current flip simulation. It also valid for this node here, okay, the flip mesh. It's crucial. Okay, so this is my fix happened to this job. Okay, looks good. Okay, so let's assign my material, selecting it. This is karma, and I need to create my material to near to the volume itself. So I can copy this path here and paste it here and type mtl pyro. So we can consider that we opened a new folder called mtl to this folder and create a new folder called pyro to host out our materials. So here is our material called pyro. I can assign it to volume here. I can restart the render. Okay, I need to adjust. We see some density, but we need to adjust the material itself. So I can type here the standard values. So here finally we got the correct representation of our fire. Okay, so yes. Also, I can treat this fire as light source by creating geometry render settings and all for this primitive and scroll down. Yes, treat as light source. Yes, please, and make the diffuse intensity higher and specular higher. So this now emitting much more light. So we treating this flames to emit lights. We can insanely increase this. So yeah. Okay, what else we can do? We can assign different shader instead of this green shader for the liquid, as it's inheriting the material from the parent. So here is this parent here, yes, from material binding. So the reference 7, the parent of all meshes beneath it will take will take same color material. Let me make it OpenGL. So it become green. So that's mean it's taking this material and assign it to the mesh, our mesh. So I need to make a new material for this liquid. So here I can create standard material X, standard perfect, and call it for thick width or flip. Okay, we can turn off this base, or we can make it like this color, for example, and we can start increasing the transmission a little. So here is our flip material. So I can type flip here, bring the flip shader and make it at this place, flip, and assign it to mesh, this mesh. I suppose, or it should here at when I exported the flip mesh, I should give it a unique name or unique path. So it was better for me to create our type here flip, for example. So it created a new primitive or container and stored inside of it this mesh. Okay, but I didn't make this. I will make it in the future examples. Okay, if I start rendering it with Karma, it will getting now some different colors. And if I choose X view for this example, will be faster for sure. We can put a dim light here to see better. So now here is a mesh. Become very transparent here. So we can control the look. So it's like look like oil. So yes, we are done with this. This method will work fine with FX artists individually. If you are any artist, you are freelancing, or if you are working in a studio, you can use the Karma power. And if you are an artist individual, you can use XView power also. So this method is pretty neat. All we have to do that we can just for now drop USD these layers here, and we can flatten, not flatten stage, let's leave it like this, and we can say for now this is our FX layer to be published for other departments .usda here, and just save to disk and copy this path here and append it to whatever it comes. So sublayer, append our USDA file here to original one. It will be same. So yes. Okay, I hope you found this tutorial very useful for you, and see you later. Thank you. Bye bye.